So let's say you want to test a REST API. There is a lot of choices that you need to make. You have to choose query parameters. There are choices that you need to put in the path elements. You have body payloads, possibly in JSON. It's a lot of choice that you need to make. And the goal here is that we want to generate test cases to maximize different properties. Like, for example, you want to cover every single endpoint of API, or you might also want to optimize things like code coverage on the back end. And of course, if you do these things by hand, if you have to write test cases for every single endpoint in an API, that is going to take quite a lot of time. So what about if we could generate test cases automatically? And I'm not talking about the execution of the test cases, but making all of those choices related to query parameters and body payloads all automatically. So that's the idea. And if you manage to do it, let's say that you have a tool that can generate test cases by making all the choices in the body payloads, query parameters, and so on for every single endpoint, then what are you going to do with those test cases? There are at least two possible things that you can do. First, what if the test case show you the presence of a bug? Like, for example, if a test case show a 500 status code server error, or if a test case tells you, oh, this response is not matching what is declared in the schema. So if you have an oracle that tells you if a test case is kind of failing, that oracle, you can use that information directly and possibly fix the API. But even if you cannot detect any faults, if you get a set of test cases that are generated and those are executable, then you can use those test cases for regression testing to see if future changes in the API is going to break existing functionality. So there are at least two different things that you can do if you can automatically generate test cases. So fuzzers. Fuzzers are tools, as also discussed in the previous presentation, that generate test cases automatically. So they can use a lot of different kinds of strategies. The most simple is doing things at random, like random testing. Or there is a lot of work on using more sophisticated techniques with AI, like from LLM to neural networks, genetic algorithms, and so on, to trying to get even better test cases. With, again, the goals to maximize different kind of coverage, but also to find faults. And the point is, you can, when you have this kind of tools, you can generate and evaluate millions of test cases automatically in just a couple of hours. And there has been a lot of work on fuzzing in a lot of different domains, like parsing libraries or unit test cases, but you can also do it for REST APIs. But the use of fuzzing in the context of REST APIs is a bit more recent, in the last 5 years. And if you want to use fuzzing today, there are quite a lot of tools that are open source. I'm personally aware about at least 25 different open source tools on GitHub that you can use. But there are 4 major tools that you can use today. And when I talk about major, it's mainly on popularity on GitHub, like Restler from Microsoft Research, Schemathesis, Cats, and EvoMaster. And yeah, so those things are tools that already exist today. And some of them are actually a bit quite popular. And as I say, they are open source. So you can just go on GitHub and try them out. It's not that you have to pay any license or buying tools or anything. Most of those work is open source. So what do these tools need? I mean, you can generate random bytes and send them toward a TCP socket, but you don't get much out of it. So the idea is that most of these tools will take an OpenAPI schema as input, because they're going to send a request, but structurally correct. They will send a request that match what is expected in the schema. But then there is a lot of options that needs to be set, like I say, query parameter and body payloads. So what happens if you want to consider an example, a trivial example like pet store from Swagger, what happens if you point a fuzzer toward that example API? What's going to happen? What can you expect? All these tools will analyze the schema, the OpenAPI schema of that API, see what endpoints are available, see which query parameters, see which body payloads, and then start to generate test cases automatically based on that information. And then, after you run them for 5 minutes, 5 hours, or any amount of time you want, they can generate test cases as output, possibly in different formats, depending on the tools. I mean, you could get test cases in Python, Java, or Kotlin. It depends. And then, if those fuzzers can identify bugs in those API, they will tell you, hey, I have this test case which shows you this bug. So, for example, I'm the author of EvoMaster of one of those tools. And what happens if you want to try it? Most of those tools are on command line. Several of those tools are even on Docker, so you don't even need to install them if you just want to try them out. And the main things that they need is to know the schema, where it is. Then you can pass more parameters, like in this particular case, I say, hey, I don't want to spend 2 hours, let's just try it for 30 seconds. And I'm not a particularly nasty guy, so I don't want to do a denial of service attack here, so I'm saying, please don't make more than 60 calls per minute. So I'm limiting myself. So what happens if you copy and paste this in a command line? You get an execution of the tool. Of course, if the first time you use it, then it will need to be downloaded from Docker, but that is automated. And then what you get out from fuzzing this API for 30 seconds? You can get an happy day scenario. For example, in this particular case, by default, it generates test cases in Python. And it's just calling that endpoint with find by tags with some query parameters that are correct, but with random values. And then it checks, oh, everything is fine, it's a 200, happy day scenario. However, you can also find bugs. Like in this particular case, this is another test case in which it constructs some more sophisticated body payload. Everything seems fine, because in the response you get a 200. But for some strange reason, that API doesn't define 200 as a correct answer. Apparently, for that endpoint, you only expect to have 400 or 404. And I ran these things, that was the end of September. When I ran the same things last year, I also got some 500 bugs, but apparently they fixed them. But there are still these kind of things. And the point is, this is quite, you just get it automatically by just running for 30 seconds. But then, of course, there are more things sophisticated, especially when you look at security like BOLA and so on. That, of course, takes a bit more time and a bit more configuration. But, of course, you might evaluate millions of test cases, but you don't want as output millions of test cases. That is not very manageable. So these tools, most of them will give you a minimized test suite. 50, 200, 300 test cases, depending on different properties. Like, for example, the number of endpoints, and so on. And then, of course, you also want to get some reports, some web report that you can interact with, that shows you, oh, you only tested, out of 20 endpoints, only 13 was possible to get a 200 family, and so on. And then, of course, you want also to be able to look at every single endpoints and see which test cases were generated for those endpoints, what kind of status code you got back, and if there was any specific fault that was found. You can look at the test cases, you can use the test cases directly, but you might also want to look at some kind of general report. So, as I say, I'm the author of EvoMaster, so that is what I've been working on, and it's not really something new. We've been doing this since 2016. So these things has been fuzzing in general is even much older. It's from at least 20, 30 years ago. I'm working as a professor at the university, so I'm not a tool provider. Everything we do is open source. And we get paid by the government. That's how we found this kind of research. But also we do quite a few collaboration with industry. Because you say, OK, let's apply a fuzzer on pet store. Okay, who cares so much? But we also want to check these things in industry with actually real-world applications. So for example, we apply these things in large companies like Volkswagen in Germany or Meituan in China. And those, especially at Meituan, they use these tools on thousands of APIs every day in their continuous integration systems. So these things can also be used in practice. It's not just academic research, but you can use them directly. So we do quite a few work on open source API. I mean, when we do experiment, when we try new things, there is a lot of APIs out there that you can use, especially in the public sector. There is a lot of API on GitHub from, for example, especially in countries like Norway. A lot of the systems, APIs in the public sector are actually published online on GitHub, so we use quite a few of those. But of course, it's also always good to get some feedback directly from developers. Because, okay, you can have a tool, you can generate test cases, you can do all these things in the lab, but how developers and testers are going to use them? Do they like how a test case is generated? And so on. Because there is much more that needs to be done, especially regarding usability, readability of test cases. Because you can generate test cases automatically, but then are those test cases easy to read or easy to understand what we're doing? So there is a lot of challenges here. And there is a lot of research in academia on a lot of different techniques. Because as I said here, I didn't go into the details of how these tools work internally. I haven't spoke about genetic algorithms. I haven't spoke about neural networks here. Those are low-level technical details. As a user, you see a black box. You say, oh, this tool, go to this API, give me test cases. What is inside is very complex and sophisticated. So what happens here? We do experiments. We take, let's say, 50 APIs from GitHub. We run and compare different tools. And we say, oh, we achieve 40% code coverage. On the HTTP request, we cover with 200, maybe 60% of them. Good, but not good enough. What is left? Why don't we get 100%? And to do that, there is a lot of research and design of different techniques to improve performance. So we are not there yet, but the techniques that we have are already usable today. And so what are the goals? Covering them all. A lot of different oracles that you can use to automatically detect faults. Like, for example, today in this conference, a lot of people have been speaking about BOLA. And those things, we have them today, but we didn't have them 6 months ago. So there is a lot of security properties that we have introduced as check automatically, but we haven't touched maybe just 10% of the OWASP top 10. So there is more things that can be added. But of course, that requires research. So not available today, maybe available next year. And another important thing is test readability, because when you generate test cases, those are not just going to be ignored, but you might have test engineers that are going to look at those test cases and maybe extend them. Use them as a starting point to write more test cases and use them as a template. Or if those test cases reveal a bug, you might have software developers that use them for debugging. So also the readability of the test cases and how they look like has an impact here. But of course, you can download the fuzzer. Why don't you just use an LLM? I mean, it's 2025. Isn't LLM the answer for everything? Question, yes, you can. But it all depends on how much information you have. If the only information is the information that is in the schema, result will suck. Because most of the logic, most of the things is in the API itself. So whatever you do, you need to interact with the API. You need to have dynamic feedback to be able to generate better test cases. So yes, you can do it. You can use an LLM. You will get some test cases. Hopefully, most of them will compile. We will have to spend a bit of time to fix all the hallucination about methods that don't exist, and so on. Or you can use a specialized tool. So in conclusion, And I'm actually quite fast because I thought I have too many slides, but it's the end, it's the evening. You cannot go to have a coffee break earlier. So, in conclusion, there is a lot of success stories about fuzzing, not just the REST API. If you look about, say, fuzzing libraries, you can go back 20 years. There is a lot of success stories out there. There is more now about REST API and APIs in general. I only spoke about REST, but with this tool, we also fuzz GraphQL and RPC APIs. And it's getting a lot more impact in academia, and also seems like with you practitioners, considering that 2 talks were accepted on this topic in this conference. And there are several tools, open source tools available. I am biased. I mean, I'm the author of one of those about EvoMaster, so of course I'm going to tell you it's the best. But you shouldn't believe me. You should try it by yourself. But you can also try other tools like Schemathesis and CATS. And I think I'm done. Thank you very much.